So what we're going to do today is inverse trig integrals. These are another thing that I would say try your best to memorize it, but if you don't, it's not going to be more than one question on the AP test, and so you're not going to be a huge loss if you don't remember it for the AP test. We're actually not going to do example 2. It's, again, a little unnecessarily complicated, so we're going to not do that one right now. It would take a while, and I don't think it's really that practical. So we're going to skip that one. The next section here, we have some reminders on some arctans and sines here. The good thing is you don't have to do all of the inverse functions. The two that you need to know are arcsine and arctan. All of them, the derivatives you should know, but the only two integrals that you're required here to know are the arcsine and the arctangent. Remember, arc is the same thing as inverse. It's just the way that we write it. So anyhow, here's your derivative formulas. If you remember back when we did that, the derivative of the inverse sine of the arcsine is u prime over square root of 1 minus u squared, and then arctan is u prime over 1 plus u squared. The integrals are written here. It's just kind of the opposite, right? So just taking the integral of this, and you end up with the arcsine. Integral of this, you end up with the arctan. Okay. Now, where it gets a little more complicated is this doesn't always translate as easy as we want to, because it's not always just like the arcsine of x. Here in this case, we actually have an x over 2, which means that this is actually the arcsine of 1/2 x. So written as x over 2, but it's the same thing as 1/2 x. So that complicates things a little bit because this isn't just x, it's a number with an x. So anything with this scenario is what we have these two formulas for. And so in the arcsine in particular, the way that this is sort of classified as this is your u, this is just generally your x here. And then we have this other variable a, which is a constant that's down there. Now this gets a little bit complicated, so just bear with me as we do this, but knowing that you probably won't actually have to do this on the AP test. The hope is that you won't. All right, so our first warm-up example we're going to do is a derivative of the arcsine of x over 2, and then we'll get to the integral. All right, so let's try it. Here's your formula if you forgot. It's u prime over the square root of 1 minus u squared. So the u is this. This whole thing is the u. So the derivative u prime, or y prime, is going to be u prime. So what's u prime? If this whole thing is u, x over 2 is u. What's u prime? Yeah, just half. Yep. This is like 1/2 x over half. U prime is up there. And then it's over the square root of, and then it's the 1 minus u squared. So this is the formula we're using here. U prime over the square root of 1 minus u squared. So then it's 1 minus x over 2 quantity squared. Now we're not actually going to leave it like that. We're going to rewrite it eventually in a different way here. Because we got like a fraction within a fraction, and this can also be squared. So we're going to manipulate this a little bit. This 1/2 on the top would actually be the same as putting 2 on the bottom. Because if you were to keep change flip, you keep top, you'd switch, you'd flip and multiply. So it's actually the same as putting 2 on the bottom. And then this becomes the square root of 1 minus, and then when you square this, you square the x, is x squared, and you square the 2 is 4, you write it as 1/4 x squared. Now, in my opinion, this would be a fine answer. That should be a fine answer. But to kind of prove what this formula is here, so that there's not a number here. Notice in this formula, there's not a constant hanging out here. What we're going to do is actually take this constant into the square root there. So in order to bring this into the square root, do some math tricks here. What's another way that we could write 2 with the square root? It would equal the same thing, but it wouldn't be 2, it would be, square root of 4. So if we kind of view it like this, the square root of 4, that's the same thing, right? And then you're allowed to actually bring that 4 in. So that 4 has to multiply times both of these, so we end up getting 1 over the square root of 4 minus x squared. Because this 4 then is going to get multiplied into both of these. So then if you were to look at this little formula here, for the arc sine, it's written in this formula as a squared. So this being let's say we're starting with this problem here. What would a be in this problem? Close. Nope. Yeah, 2, because it's a squared. So a would actually be 2. And then u is going to just be x, because it's something squared. So then a is 2, u is x. Right? So then plugging it into this formula, and then we'd have to make sure that also this is u prime up here. So u prime would then be 1. So how this would work here then is then if we were to integrate this, the integral of this, it would be the arc sine of u over a. So u is x, a is 2, plus c. And that is what we started with there. So this, I know is complicated. It probably looks complicated, seems complicated. It is. But again, this will not be a main feature of the AP test. So. And I would say, you can memorize this, but I'm not going to require you to memorize these 2 formulas. It's a little ridiculous. All right. So let's go ahead and try a couple of these examples. So first thing would be, let's try to figure out which of the 2 these all match with either an arc sine or an arc tangent right now. I'll make sure that I don't get any. At least the first one here. Okay, so number 3 here. This is obviously going to be arc sine, right? And actually, I think it's the one we basically just did. Yeah, this is the one we just did. So we can go ahead and write it out. But what we want to do is identify the a. So a here is going to be 2. U is going to be x. And then I'm going to go ahead and write u prime as well. If u is x, u prime would be 1. So we basically want to make sure we got everything in the right spot. So this is u prime, right? This is a squared, so that's be 2 squared. And this is minus u squared. So our formula up here is this a squared minus u squared and the u prime on top. And that all matches. It won't always be the case where it matches exactly, but this does. So then our answer is just the arc sine of u over a plus c. So arc sine of u over a plus c. Okay, so this next one, it doesn't have the square root. So when you're doing these, if you have the square root one, it's going to be a sine. If it doesn't have the square root, it's probably going to be the tangent. Right? And so what we're looking at on this one is this formula here. It's u prime over a squared plus u squared. So I'm going to rewrite this a little bit just to make sure it's in the right order here. So this would be the same thing as dx over, and actually I don't really like the dx up there either. So I'm going to write on the side, just like 1. And these are actually in the wrong order. The constant should go first, so I'm going to put the constant first. And how should I maybe rewrite 25? Because it's a squared plus u squared. Right, but that's 5 squared. And then I'm also going to rewrite this 4x squared too. I'm going to write it as plus 2x 1u squared. Because we got to take into fact that that 4 has to be squared as well. So then it's a little easier to pick out our things here. So then we're going to do the same thing. Our a is going to be 5. Right? Our u is going to be 2x. And then u prime is 2. Now the only problem with this is it doesn't quite match, because this works, but in this one we got a 1 up there instead of a 2, right? So here's how we fix it. This is where it gets a little abstract here. We need that to be a 2 up there in order for it to be the arctangent. So I'm going to write a 2 up there. But I'm not allowed to just change a 1 to a 2. So how we offset that is out here I'm going to write a 1/2. Because 2 and 1/2 cancel each other. So let's just do a little math trick there. Does it make sense of why we're allowed to do that? 2.5 is the same thing as 1. Right? So we need it to match in order for it to work. So then when we do this, let's look at the arctan formula. So we're gonna have this 1/2 out here first. Let's just kind of hang out in front. And then it's going to be 1 over a. That's our formula. It's a little more complicated. It has the 1 over a there. So 1 over a is going to be times 1 over a, 1 over 5, and then it's arctan, and then it's the same u over a here. U over a, let's see. So then u is 2x over 5 plus c. And then let's do better actually. Let's just go ahead and multiply those, so it'll be 1/10 arctan 2x over 5 plus c. Let's try one more here. So number 5, this is also an arctan one. You can tell it because it's a something plus, something with an x squared in the bottom. We're going to have to manipulate this one again, kind of like we did the last one. So let's try to rewrite this as something squared on the bottom plus something squared. So we've got 8 up here for now. So how do I rewrite 3 as something squared? What squared is 3? Yeah, square root of 3. Yeah. So whereas is the square root of 3 squared plus and then the other 2x. So now let's try to pick out our a, our u, and our u prime. So a is square root of 3. U is 2x. U prime is 2. So here I've got to change something again. We need to make the top 2. It's not going to be the same exact strategies within the last one. Any idea how we could change that 8 to a 2? Okay. Only that's you got the right idea. The only thing, so let's just try it. So if I were to change this to a 2, what would you say? Put it in front. In front. Well, I know I have to make that 2. So I've got to change it to 2. But what do I have to do to offset that? Yeah, put 4 in the front. So we know we're going to change it, so we can just go ahead and change it, and then basically figure out what operation do I have to do to get this 2 to an 8. You got to multiply that 4 to 8. Yeah, you have to change it. Yeah, got to change it, or else it won't be an arcane. Because then 4 times 2 is 8. So like this one, we had to change it to a 2. So then we think, well, how do I get from 2 to a 1? Well, you multiply 2 times a half. 1. So I know that's confusing. This is not something, again, that you might not even remember on the AP test. And that's okay. You will have seen it once. All right, now we're ready. So now we can just follow the formula. So it's going to be 4 times, and then it's our 1 over a. So it's going to be 1 over square root of 3 arctan u over a. So 2x over square root of 3. Now this is a definite interval, so it's by from 0 to the half. Means we got to plug that in. Now, what I would do in evaluating this constant in front here can pull out. There's no reason to keep it with each section. I'm going to write it as 4 over square root of 3. Pull that out. And then we have to do the arctan and then we got to do 2 times a half over radical 3 minus arctan 0. And we get radical 3. This is going to be the arctan just 1, 2 times a half is 1 over radical 3 minus the arctan of 0. All right, so now we got to draw on some other prior knowledge here. And that is, you got to remember how you figure out what the arctan of 1 over radical 3 is and what the arctan of 0 is. This is a non-calculated question. So remember how inverses work, is you think in reverse. Generally, you would say, oh, what's the tangent of like pi over 6? This is saying, this is the answer, give me the value, basically. Right? So, now tangent's a little bit more challenging, right? Because you gotta think sine over cosine. So you got to think the y coordinate over the x. So basically, what we're thinking here is what y over x equals 1 over radical 3. The easiest way to think about this is in your coordinate pairs, you've got, well, you got your first one actually is radical 3 over 2 if you're working your way up the circle on that half, right? Working your way up, and then you got radical 2 over 2, radical 2 over 2, and then you've got your 1/2 radical 3 over 2. You can eliminate the middle one, right? Because it doesn't have a radical 3 in it. So it's either got to be at pi over 6 or pi over 3, right? Those are your two options. So think about which one of those would simplify to 1 over radical 3. Which one could go with you? And now it's the y over the x. So is it going to be radical 3 over 2 over a half? Would that reduce to 1 over radical 3? Nope, that would not, right? Because that would just reduce to radical 3. It's got to be this one. Y over the x would flip. The 2's would cancel, but the radical 3 on the bottom. So we want pi over 6. That value in itself can be a challenge to figure that out. It'd be kind of a bummer to figure out that that's the arctangent and then get all the way to that part and then miss that value. Kind of disappointing, right? To do the integral right and then miss what that value is. Look skeptical.
Why isn't the second one the right one? Is it
Yeah, so it'd be 1/2
one half over?
radical 3 over 2. And you keep change flip and it'd be a half times flip it 2 over radical 3.
Oh, is it?
And then the arctan of 0, think about where you get 0. Well, here your coordinate is 1, 0, and it's the y over the x, so it's 0 over 1, which is 0. So it's 0. Whereas this one at pi over 2, that would be 0, 1, or sorry, yeah, 0, 1. And the y over the x would be 1 over 0, which would be so it's at 0. So our answer then, we just multiply that 4 pi over 6. 4 and 6 can reduce, so we get 2 pi over 3 radical 3. And really, you should never leave a radical in the denominator. So you really should be 2 radical 3 pi. Because you multiply here by radical 3 over radical 3. And that would be over 9. Because radicals would cancel over 3 times 3. So 2 radical 3 pi. And you can see why that would not be an AP problem, because you have a lot of multiple choice questions. They're not going to give you one that's going to take you like 15 minutes. And if it does take you 15 minutes, I would say just cut bait and move on to the next one, because you don't want to spend 15, 20 minutes on one multiple choice question and then miss other ones because you don't have enough time to do them. All right. We just got 2 minutes left. Let me pick out like a couple problems here that you could try. There's some more to this.
Maybe just really teach you when to click the losses and just move on.
And then, yeah,
It's kind of frustrating.
yeah.
Just how music goes kind of.
Yeah, I didn't do the first time I took the ACT back in the day. I remember not doing that, and on the math too, which math was my strong suit, but I didn't finish just because I was not facing thinking. Alright, so the best ones to do here are going to be number 1. Good one. Try that one. Number 5. I guess you can number 2 too. Three already. Actually, number 4 could be doable. Yeah, it's better than number 6. So try those 4. So you can obviously see that these two are arc sines and these two are arc tans, right? Because the one with the square root's got to be the arc sines. The one with the not square roots are arc tans.